Controlling a remotely mounted exhaust fan from multiple bathrooms using motion sensors presents several options, each with its own advantages and disadvantages. Let's explore 3 potential solutions and discuss important considerations for implementation. Firstly, consider using motion sensors with a built-in relay output. This involves selecting motion sensors that are specifically designed to activate a relay when motion is detected. The relay contacts from each motion sensor are then wired in parallel to the coil of a separate relay that controls the exhaust fan. When any of the motion sensors detect movement in a bathroom, its internal relay closes, energizing the common exhaust fan relay coil and turning on the fan. Secondly, let's look at using single-pole motion switches wired in parallel to a relay coil. This approach involves using standard single-pole motion switches, similar to those used for controlling lights. These switches are wired in parallel, meaning that all the wires connect to the same points to the coil of a relay that controls the exhaust fan. When any of the motion switches detect motion, it closes, energizing the relay coil and activating the exhaust fan. However, this method carries the risk of backfeeding. Backfeeding occurs when the activated switch sends voltage back through the other switches that are currently in the off position. This can potentially damage the switches or create other electrical issues. Thirdly, consider motion switches triggering smart relays. This more advanced approach utilizes smart relays, which are electronic devices that can be controlled and configured remotely. Instead of directly wiring the motion switches to the exhaust fan relay, you connect them to the smart relays. The smart relays are then programmed to control the exhaust fan asynchronously, meaning that each motion switch can independently turn the fan on or off without affecting the other switches. This eliminates the backfeeding issue and provides greater control and flexibility. Before implementing any of these options, it is essential to consider several important factors. Firstly, the cost of the components, including the motion sensors, relays, and wiring, is a major factor. Option 1, using motion sensors with built-in relays, is generally the most cost-effective, as it combines the sensor and relay functions into a single device. Option 2, using single-pole motion switches in parallel, can be slightly more expensive due to the need for a separate relay and the potential cost of addressing backfeeding issues. Option 3, using motion switches to trigger smart relays, is typically the most expensive option due to a higher cost of the smart relays themselves. Secondly, the location of the motion sensors is crucial for ensuring proper detection and avoiding false triggers. The sensors should be placed in a location where they can reliably detect movement within the bathroom without being activated by activity outside the bathroom. For example, avoid placing the sensor directly in front of a doorway or window. The wiring configuration must be carefully planned to comply with electrical codes and prevent any potential hazards. All wiring connections should be secure and properly insulated, and the circuit should be protected by a circuit breaker or fuse of the appropriate size. It is strongly recommended to consult with a qualified electrician to ensure that the installation is safe and meets all applicable regulations. Let's delve deeper into each option, starting with the use of motion sensors with relays. These sensors typically have 3 or 4 wires: live, neutral, load, and sometimes a ground. The live wire provides power to the sensor, the neutral wire provides a return path for the current, and the load wire is connected to the relay coil. When motion is detected, the sensor closes the relay, sending voltage to the relay coil. The relay that controls the exhaust fan is a separate device that has 2 main parts, the coil and the contact. The coil is an electromagnet that, when energized, pulls the contacts together. The contacts are a set of switches that control the flow of electricity to the exhaust fan. When the relay coil is energized, the contacts close, completing the circuit to the fan and turning it on. When the coil is energized, the contacts open, breaking the circuit and turning the fan off. The relay should be rated for the fan's power consumption, meaning that it should be able to handle the amount of current that the fan draws. This information is typically found on the fan's nameplate. Moving on to the option of using single-pole motion switches in parallel, these switches are typically simple to install and wire. They have 3 terminals: line, load, and ground. The line terminal is connected to the incoming power source, the load terminal is connected to the relay coil, and the ground terminal is connected to the grounding wire. When motion is detected, the switch closes, sending voltage to the relay coil. As mentioned earlier, this method can cause backfeeding, which can damage the switches or create other electrical issues. There are several ways to mitigate this risk. One way is to use diodes to block the flow of current back through the switches. A diode is an electronic component that allows current to flow in only one direction. By placing a diode in series with each switch, you can prevent current from flowing back into the other switches. Another way to prevent backfeeding is to use a different type of switch, such as a double-pole single-throw switch. This type of switch has two separate sets of contacts, which can prevent current from flowing back through the switch. Now let's explore the option of using motion switches to trigger smart relays. Smart relays are more sophisticated devices that offer greater flexibility in control. They can be programmed to perform a variety of functions, such as turning on and off lights, controlling appliances, and even sending notifications to your smartphone. To use smart relays to control the exhaust fan, you would first need to connect the motion switches to the inputs of the smart relays. The smart relays would then be programmed to activate the exhaust fan relay when any of the motion switches are triggered. This can be accomplished using a variety of programming methods such as ladder logic or function block diagrams. One of the advantages of using smart relays is that they can be configured to operate asynchronously, meaning that each motion switch can independently control the exhaust fan without affecting the other switches. This eliminates the backfeeding issue and provides greater control and flexibility. Another advantage of using smart relays is that they can be integrated with other smart home systems, such as lighting control systems and security systems. This allows you to create a more comprehensive and integrated home automation system. In addition to the above options, there are several other factors to consider when controlling a remotely mounted exhaust fan with motion sensors. Firstly, consider the type of exhaust fan being used. Some exhaust fans are designed to run continuously, while others are designed to run only when needed. If you are using an exhaust fan that is designed to run continuously, you may not want to use motion sensors to control it. Secondly, consider the size of the bathrooms. If the bathrooms are small, you may not need to use motion sensors to control the exhaust fan. In this case, you could simply use a timer switch to turn the fan on and off. Thirdly, consider the humidity levels in the bathrooms. If the bathrooms are prone to high humidity levels, you may want to use a humidistat to control the exhaust fan. A humidistat is a device that measures the humidity level in the air and turns the fan on when the humidity level exceeds a certain threshold. Fourthly, consider the noise level of the exhaust fan. Some exhaust fans are very noisy, which can be disruptive to the occupants of the building. If you are using a noisy exhaust fan, you may want to use a sound attenuator to reduce the noise level. Fifthly, ensure compliance with relevant electrical codes and standards. The National Electrical Code, or NEC, provides guidelines for safe electrical installations. Some relevant articles include 210.24 regarding branch circuit requirements, 250.118 concerning types of equipment grounding conductors, 300.11 for securing and supporting wiring methods, 310.15 for ampacity of conductors, 404.2 regarding the location of switches, and 430 covering motors, motor circuits, and controllers. These codes address conductor sizing, overcurrent protection, grounding, and wiring methods, ensuring the installation is both functional and safe. Improper wiring or component selection can lead to hazards, so consulting with a qualified electrician is highly recommended. In summary, controlling a remotely mounted exhaust fan with motion sensors requires careful consideration of several factors, including the type of motion sensors used, the wiring configuration, the cost of the components, the location of the sensors, and compliance with electrical codes. By carefully evaluating these factors, you can select the best solution for your specific needs and ensure a safe and efficient installation. Remember to prioritize safety and consult with a qualified electrician to ensure that the installation is performed correctly and meets all applicable regulations.